Number 4, we've got two conducting spheres with a common center, and the outer shell is grounded. The inner shell is positively charged. So the first step is to solve for the net charge. And since we're given Q, we know the equation for Q is KQ over A squared, because that's the surface of our inner shell. Or sorry, not A squared, just A. And then all we have to do is solve for charge. So Q is VA over K. In your answer key, they'll work out the K value is 4 pi epsilon naught in the numerator, but it's the same answer. So this is A, answer VA over K. Use Gauss's law to determine the magnitude of the electric field in the region between the shells, and that is just our 4 pi r squared, because between the shells is some arbitrary value distance of radius r, and then our Q enclosed is our positive charge. So we would substitute this into the equation and then divide that by epsilon naught. So what we have here is, actually, they don't even do the substitution. All they do is solve for the Q enclosed. They simplify everything down for the electric field. And if I divide 4 pi r squared to the other side, I end up with 4 pi epsilon naught r squared. And again, you can simplify that to this equation right here. For part C, it says determine the potential difference between the spherical shells. Well, we're going to use our equation. So this is C, that delta V is equal to the negative integral. And I always start from the higher potential or the higher radius to the lower radius. I know that ends up giving me a positive charge. If you go from A to B, then you're going to get a negative change of potential, and then you just change the sign of that by flipping A and B in your final equation. So here we've got an electric field of K, Q enclosed over R squared dr. Let me write the equation here just in case you don't have it memorized. And then our K, Q enclosed is just, is just a constant. So r to the negative 2 dr gives us negative K, Q enclosed of negative 1 over r. And again, we're going from A to B. The negatives turn into positives, and we end up with 1 over A minus 1 over B. And in your answer key, it just leaves it in that form as well. For part D, it says develop an expression for the capacitance of the system in terms of A, B, Q, and fundamental constant. So this is just Q over change in voltage. And if we plug in our change in voltage into the denominator, it would be Q enclosed over K, Q enclosed 1 over A, 1 minus 1 over B. And then our Q enclosed ends up canceling, and I get 1 over K times 1 over A minus 1 over B.